Hey, what's up guys, ProCoderGamer here, back with another video where today we're diving into something completely new for me, building my very first gaming PC from scratch. So let's get into the video. So here I've got all of the components laid out right here, and I'm excited to see how it all comes together. So without further ado, let's jump right into it. Alright, let's start with the heart of our build, the motherboard. Here, I've got the Asus ROG Strix Z790E motherboard with integrated Wi-Fi 6E, supporting Intel's latest processors and up to 128GB of DDR5 RAM. It has PCIe 5.0 slots for high-performance graphics cards, advanced cooling, and connectivity with USB Type-A and Type-C ports. Featuring Supreme FX audio and customizable RGB lighting, is perfect for enthusiasts who prioritize top-notch performance and reliability in their PC setups. So here, we can already see the motherboard itself with another box that says, "Welcome to the Republic." So this box has the Wi-Fi 6E antenna. It is a crucial component that ensures I can leverage the motherboard's integrated Wi-Fi capabilities effectively once everything is assembled and ready to go. So below the motherboard itself, we can see the quick start guide as well as some other things. Inside of here, there are some more things in here that I won't be needing when building the PC. Now we've got the processor, basically the brain of the computer. Here I've got the Intel Core i7-13700K, which is going to give us some serious power. So opening the box, we can see the CPU and another layer of packaging. So now I'll be taking the CPU outside of this other box. There is the Intel Core i7-13700K itself. Now I'll be taking the motherboard outside of its packaging. Now it is time to begin the building process by installing the CPU onto the motherboard. So first, I open this socket by lifting the lever. Next, I carefully align this tiny triangle on the CPU with the triangle on the socket for the CPU. Then I gently place the CPU onto the socket of the motherboard, making sure not to bend any small pins. Once this is in place, I close the lid and push down until the cover comes off. Then I gently lower the CPU locking mechanism to secure it. I did not expect to have to use so much force when lowering the lever. Now it's time to add memory to the build. The RAM I'll be using is the Corsair Vengeance 64GB of DDR5 memory. This kit contains 2 sticks of RAM, and on the back of the box you could see the 2 RAM sticks. When I got to installing the RAM, I unlocked the second and fourth RAM slots on the motherboard to take advantage of dual channel memory, since I have 2 RAM sticks. I carefully inserted each stick of Corsair Vengeance DDR5 RAM into the corresponding slots. With the RAM installed, I applied equal pressure to both sides until the RAM clicks securely into place. Moving on to storage, I got the Corsair MP600 Pro LPX with 2 TB of storage. This is a lot of storage and it'll help me a lot with recording and editing videos, as well as storing any backups if needed. So this is what the SSD looks like. It comes with its own heatsink pre-installed onto the SSD. I located the M.2 slot on the motherboard and removed the protective cover. Then, I carefully aligned the notch on the SSD with the slot. I then secured the SSD in place using the toolless installation that is very convenient. For me, this was the easiest step in building the PC. Let's ensure the CPU stays cool with the Corsair Ace 150i Elite LCD XT AIO liquid cooler. So this comes with a 360mm radiator that I will be installing on the front of the PC case. It also has a cool LCD display that will tell me the temperature of the coolant by default. So inside the box, there's an AIO pump connected to the 360mm radiator, 3 RGB fans, a splitter cable, a mounting backplate, and a hub that I can connect all the wires for my fans to so that I can control them using software. Time to prep the motherboard for the AIO cooler. So this is a mounting backplate that will be attached to the back of the motherboard. Inside of this packet, there are different types of standoffs for different types of Intel CPU sockets, as well as the backplate itself. The standoffs I need are in the packet that is labeled as Intel 1700, since that is a socket that my motherboard has. So I installed the backplate by aligning it with the CPU socket and threading the standoff screws through the motherboard. Once secured, I verified that the backplate sits flat against the motherboard, ensuring a stable base for the AIO cooler's pump. Now it's time to start housing all of the components in the Corsair iCUE 4000D mid-tower case that comes with 3 RGB fans pre-installed. To take off the side panels, all I had to do was loosen 2 thumb screws. By doing that, I was able to take off the panel. Inside here, we can see a box that is attached to a hard drive slot. So this box has the screws that are needed to install the motherboard onto the case. as well as some other screws. To install the motherboard, I carefully positioned it into the case, aligning it with the pre-installed standoffs, ensuring all of the I/O ports are on the side of the motherboard, aligned with the case cutouts. And using the screws provided with the case, I secured this motherboard to standoffs. To accommodate this AIO radiator, I had to remove the pre-installed case fans. So I carefully unscrewed each fan from its mounting points and disconnected the fan cables from the RGB lighting controller that also came pre-installed with the case. Now the next step is to mount the AIO radiator onto the case. So I positioned the AIO radiator at the front of the case, aligning it with the fan mounting points. Using the screws provided with the AIO cooler, I secured it onto the case, ensuring it's firmly attached and stable. Now it is time to attach the radiator fans for optimal airflow through the radiator. I mounted each fan onto the radiator, aligning the fan screws with the radiator's mounting holes and securing them evenly for a balanced airflow. With the radiator in place, it is time to install the AIO pump onto the CPU. The Corsair H150i Elite LCD comes pre-installed with thermal paste onto the CPU cooler plate, ensuring proper heat transfer right out of the box. I lowered the AIO pump onto the CPU surface, aligning the mounting brackets with the backplate standoffs and securing the pump with the provided thumb screws. To maintain proper airflow, I reinstalled the case fans as exhaust fans. I positioned two of the exhaust fans on the roof and one on the side panel of the case, ensuring they're aligned with the airflow direction, and then I secured them with screws. I then connected all of the fan wires to the Commander Core XT that came with the CPU cooler for centralized control and management. Time to power this build with the Corsair RM1000E fully modular PSU. This is a 1000 watt power supply unit, ensuring my PC can run at its full potential. I carefully unboxed the Corsair RM1000E fully modular PSU, ensuring all components are intact. In addition to the power supply itself, this box includes modular cables, mounting screws, and the power cable. So before mounting the PSU, I carefully connected the necessary modular cables from the Corsair RM1000E to ensure all components receive power, starting with the huge 24-pin motherboard power cable, the 8-pin CPU power cable, and the PCIe power cables for the GPU. This way, I can easily connect the cables to their respective components once the PSU is installed. Next, I secured the power supply into the case, aligning it with the mounting bracket and then securing it with the screws to ensure stable power delivery, and I made sure that the PSU's fan was facing the appropriate direction for optimal airflow. Now it's time to connect everything and manage all of the wires.
One eternity later.
Finally, I've connected the motherboard, CPU, and the front panel connectors. Then I ensured each cable is securely connected and routed cleanly. Now, there's only one more step until I finally complete the PC build. Time for the graphics card. Here, I have the Asus ROG Strix GeForce RTX 4060 Ti with 8GB of virtual memory, which is going to deliver great performance for gaming and video editing. So this card features advanced cooling technology, customizable RGB lighting, and enhanced durability with its reinforced frame. Plus, it supports ray tracing and AI enhanced graphics, like DLSS, for example, making it perfect for high quality visuals and smooth gameplay. So first we have the outer packaging that keeps the GPU safe during shipping. So opening the box, we can see the GPU itself encased in an anti-static bag. This helps prevent any electrostatic discharge that could damage the components. Alright, it's time to remove the GPU out of the anti-static bag. And here it is, the ROG Strix RTX 4060 Ti itself. The design looks fantastic with the ROG logo and the sleek metal backplate. The triple fan cooling system is impressive and should keep the temperatures low even under heavy load. As you can see, there are protective covers on all the ports, including the HDMI and display port connectors. These covers help protect the ports from dust and damage during shipping and handling. Now it is time to install this GPU. First, I had to remove the slot covers on the case. Then, I had to carefully align the GPU with the PCIe slot on the motherboard and gently press it into place until it clicks. I then secured the GPU to the case using the screws that came with it. This ensures that the card is stable and well connected for optimal performance. Now that the GPU is installed, it's time to test the PC. The moment of truth. It is time to power on the PC for the first time. First thing is to turn on the power supply switch. With that, it's time to press the power button in 3, 2, 1. It works. The fans are spinning, the RGB lights are on, and the monitor is displaying the BIOS screen. This is a good sign that all of the components are properly connected and functioning. With the BIOS setup complete, I installed Windows 11 Pro, as well as the needed drivers, my favorite games, video editing tools, and benchmarking software to test the performance of my new build. With everything set up and ready to go, it's time to test this PC by playing some games.
Perfect. Please move quickly to the chamber lock, as the effects of prolonged exposure to the button are not part of this test.
So there you have it, guys. My very first time building a gaming PC from scratch. It was an incredible experience, and I'm thrilled with how it turned out. If you enjoyed this video, leave a like, and if you haven't already, go ahead and subscribe to my channel, and turn on notifications to never miss out on another upload. I hope you have a good rest of your day, and peace out.